Welcome students to GS Maths. Continuing my chapter of indefinite integrals, we will discuss more types of integrals from this very chapter, right? But before starting, I hope that you must have watched my previous lectures based on this topic, so that the types of the integrals which we have already discussed are now very clear to you. The concepts, the methods, how to solve them are clear to you. I hope so. Now, starting straight away, I have discussed this type right in the previous lecture. In that lecture, what I did, I substituted the value of sin x and cos x in terms of tan x. Now, then substituted tan x equals to t and secant square x dx was equal to dt, and then we proceeded. Right? Now, there is some alternative method to evaluate this, a very easy method. Now, let me explain this with an example. It is integral of dx, say it's evaluate integral dx upon, it is under root 3 sin x plus cos x, under root 3 sin x plus cos x. Right? Now, let under root 3 equals to r sin theta or r cos theta. Let it be r cos theta. Now, let 1 equals to, coefficient of this is 1, equals to r sin theta. Divide these two. This is your number 1, this is your number 2. It is second divided by first. R sin theta upon r cos theta is tan theta equals to 1 by root 3. So 1 by root 3 is tan of pi by 6. That is tan 30 degree is 1 by root 3. So theta equals to pi by 6. I get this value. Right? Now if I square both sides, I get sin square theta plus cos square theta is 1. R square is common. 1 square plus 3 square, that is 3. I get 4. So R equals to 2. 1 square is 1. Under root 3 square is 3. That is 4. I take the under root. I get R equals to 2. Now my question reduces to what I wrote. Integrate dx upon, under root 3 was written as r cos theta, sin x as it is, plus 1 was written as r sin theta, r sin theta cos x. Now this is dx upon r cos theta. What is theta? Theta is pi by 6. What is the value of r? 2. R is also there, I take out common. So 1 by 2 is common, that is r की value was 2. So 1 upon 2 I have taken common. Now what is cos theta? Cos theta is pi by 6. That is right as such. Right, sin x cos theta plus cos x sin theta. That is 1 by 2 dx upon, this is formula of sin a cos b plus cos a sin b. This is sin of a plus b. This can be converted into cos a plus b, cos a minus b, sin a plus b, or sin a minus b formula. Now, what is the value of theta here? That is half. It becomes what? 1 upon sin cosecant of x plus theta dx. Now, what is integral of cosecant? It is log of cosecant x plus theta minus cotangent x plus theta plus c, where theta was equal to pi by 6. Just write the value, where theta equals to pi by 6. Like this. This question can be done, this type can be done like this also. Now if you are bit sure you are a bit clear of the type, we can do it directly by, say, what I can do is, I know I can write this as dx. This you will learn after you solve few questions, right? Then you can do it directly. Say I write by 2 sin x, 1 by 2 cos x. It's one and the same thing what we are doing. 2 was here. Now under root 3 by 2, what I have done? I have divided by 2 to I have multiplied by 2 also. Now half, right? This is cos x, this is cos of 60 degree. So dx upon cos x. In place of this I can write cos 60. Cos pi by 3 plus I can write sin x. This is sine of 60 degrees. Sine of 60 degrees. Now half dx upon cos a cos b plus sin a sin b. This is cos of a minus b. Now what is reciprocal of cos? It is secant theta. Cos theta reciprocal is secant theta. So what I get? Half. It is secant x minus pi by 3 dx. Now what is the integral of secant x? It is half log secant x plus tan x plus c. This is the required answer. Directly I have done, what I have done is I have multiplied and divided by 2 the denominator, right? So I get under root 3 by 2 and half over here. I know under root 3 by 2 I can write here cos of 30. I can write sine of 30. Then it becomes sine of a plus b. What I have written, I have cos x is cos 60, sin x sin 60. This formula becomes cos of a minus b. 1 upon cos is nothing but secant. Integrate directly, we get the answer. Right? Hope this alternative method to solve this kind of or this type is very clear to you now. If you can do like this, then try it. Otherwise, just substitute the value of sin x and cos x in terms of tan x and substitute tan x equals to t, right? And then secant square x dx dt will be equal, dx will be equal to dt. Now, next type which I would like to discuss in my lecture is this integral of the form. It is like this: a sin x b cos x plus c divided by p sin x q cos x plus r, like this dx. Right? Now in this case the denominator contains a constant, right? Say plus r. So what we are going to do is, it is write the same thing, numerator equals to lambda times derivative of the denominator plus mu times the denominator as it is and plus another constant k, right? Numerator equals to lambda times derivative of the denominator plus mu times denominator as it is, denominator, right, plus of k, denominator. Let me write the full word, otherwise it likes a denom, denominator, like this, right, plus k. Then the procedure is same. Open up the brackets, compare the coefficients of sin x and cos x and constant terms on both the sides to get the value of lambda, mu and k. Then replace this numerator with this expression and then follow the suit. Now I will explain it by taking an example of this type. Now it's again a very important type. A question in the board can come from this type of the integral. Now to start with, Question is 3 cos x plus 2 integrate 3 cos x plus 2 divided by 3 cos x plus 2 divided by sin x plus 2 cos x sin x plus 2 cos x 2 cos x plus 3 like this. It was 3 cos x plus 2 divided by sin x plus 2 cos x plus 3. Now the denominator contains a constant plus 3. So what we have to do is its numerator, let me start off, cos x plus 2 is equal to lambda times derivative of this sin x का derivative cos x का derivative sin x negative sin x 3 derivative is 0, it's a constant, plus mu times denominator write as such sin x 2 cos x plus 3 and plus another constant k. Now open the brackets. Now just it is lambda plus 2 mu into cos x plus minus 2 lambda plus mu into sin x, then 3 mu plus k, constants separated out, 3 mu plus k. Now 3 cos x plus 2 on the left hand side. Compare the coefficients of cos x sin x on both sides. I get lambda plus 2 mu is equal to what? 3. Then minus 2 lambda plus mu equals to 0. There is no sin x on the left hand side. And the third equation is 3 mu plus k is equal to 2. Constant is this, constant is this. Now I can solve these two equations for lambda and mu directly. So just multiply this equation with 2. I get 2 lambda 4 mu equals to 6. That is minus 2 lambda plus mu equals to 0. This cancels out. 5 mu equals to 6 or mu equals to 6 by 5. Now mu is 6 by 5. So lambda plus 2 mu, that is 6 by 5, is equal to 3. That is lambda equals to 3 minus 12 by 5. 15 minus 12, 3 by 5. This is lambda. I get lambda from here. Just fill the value of mu to get k. 3, what is mu? 6 by 5. 6 by 5 plus k equals to 2. That is k equals to 2 minus 18 by 5. Minus 8 by 5 is the value of the constant k. Now, what we did, the numerator equals to lambda times the derivative of the denominator plus mu times denominator plus k. Open the brackets, compare the coefficients of cos x, sin x and constant terms on both sides to get the value of lambda and mu. Solve the equations. I got mu equals to 6 by 5, lambda equals to 3 by 5. Just write the values over here. 3 by 5, right? What was mu? 6 by 5. 6 by 5. And what is k? That is minus 8 by 5. Minus 8 by 5. Now let me rub this. Hope it is clear to you. That is numerator was lambda times the derivative of denominator plus mu times the denominator plus k. Open the brackets, I got these things. Cos x ke coefficients, this on this side it's 3. Sin x coefficients are this. On left hand side there are no coefficients, so I equated equal to 0. This constant compared with the constant, I get the value of k, lambda and mu. Substituted in the equation. Replace the numerator with this thing. Let me rub this off. Basically three linear equations were there to solve for lambda and mu. Then we did the thing. Now just replace this numerator, right? I replace this numerator with this, divided by sin x plus 2 cos x plus 5. I had to integrate this. Integrate this. Now what we can do now? this whole thing divided by, that is, I take out 3 by 5, it is cos x minus 2 sin x divided by sin x plus 2 cos x plus 5 dx plus 6 by 5, it is sin x plus 2 cos x plus 3 divided by sin x plus 2 cos x plus 5 dx minus 8 by 5 integral, it's dx upon sin x plus 2 cos x plus 5. Now it's very simple thing. I get 3 by 5. What is this? The derivative of the denominator is in the numerator, that is sin x derivative cos x derivative minus sin x, 5 is constant, its derivative is 0. So it will become log of sin x plus 2 cos x plus 5. Now plus 5, right? Here it was plus 5, sorry. This was 3, this was 3, not 5. It's 3. This is 3. Again 3 and again 3. Right? Now derivative of this was lying in over here. I got the value. Now this cancels. That is plus 6 by 5. 1 integral is x minus 8 by 5 dx upon, I get sin x 2 cos x plus 3. Now this is again the type where we will substitute sin x and cos x in terms of tan x. That is 2 tan x by 2, 1 plus tan square x by 2. This is cos x, 1 minus tan square x by 2, 1 plus tan square x by 2. Right? This is the type we have already discussed. It can be solved by writing the value of sin x in terms of tan x and cos x in terms of tan x. Then what we will do? We will put tan x by 2 equals to t, so that secant square x by 2 into half dx equals to dt. That becomes 2t dt. Just substitute these values and solve as discussed earlier when we discussed this type, dx upon a sin x plus b cos x plus r or plus k, whatever it is. In this case, we just substitute the values of sin x and cos x in terms of tan x, and then substitute tan x by 2 equals to t. So secant square x dx is equal to 2t dt, or whatever the derivative of tan x by 2 is secant square x by 2 into half. 2 comes here, it's 2t dt. You can very well understand this if you have watched my lectures, previous lectures, where I discussed this type. Like this, we can solve this type of integrals. Right? Today's first type of this is, I think, clear to you. Now, the next type which I am going to discuss today is very important type, and it is called integration by parts. That is u into v rule. Same as we had done in differentiation, right? But the formula is same, the method is a bit different. That is integration by parts. By parts. We call it as integration by parts. Now, integration by part means, say I have two functions, u multiplied by v dx. Right? This is equal to u integral v dx minus integral derivative of u into integral of v dx. Integration is there, I write dx over here. This is the formula which we will use for integration of two functions. that is u multiplied by v. U, integral of v minus derivative of u into integral of v. It's whole integral, so therefore it's dx over here. Now the rule which is followed is called Eilert rule. Eilert rule, where I stands for inverse trigonometric functions like sine inverse x, cos inverse x, and so on. All the inverse trigonometric functions. L stands for logarithmic functions, which contains logs like log of x square, log of x plus 1, and so on. Right? Then A means algebraic functions. Algebraic functions. Algebraic functions like x cube, say a constant 2x plus 3, or simple 2, and so on. Right? Now, T is trigonometric functions. T is trigonometric functions, that is sin x, cos x, even the squares, your tan x, your tan square x, tan cube x, secant cube x, and so on. Now, E is the exponential functions. Exponential functions. Exponential functions which are of this kind: ex, e2x, and so on. E to the power x, or e to the power ax, or e to the power 2x. Exponential functions, right? Order of integration is ILATE. Eilert rule. If I have, say, suppose x multiplied by sin x dx, right? Now, I will follow this rule for integration. For example, x is a algebraic function, sin x is a trigonometric functions. A comes first, algebraic comes first, trigonometry comes after it. So I will take this as u and this function as v and use this method of integration, right? Now say I have only sine inverse x, right, dx. I don't have two functions. Eilert rule, if I want to apply it, this is the inverse function, okay, right here as 1. Sine inverse x into 1. This is I is inverse trigonometric function. 1 is the algebraic function. I can use Eilert rule for integrating this kind, right? You can note down this, just memorize it. Memorize Eilert rule. I stands for inverse trigonometric functions, L stands for logarithmic functions, A stands for algebraic functions, T stands for trigonometric functions, and E stands for exponential functions. Now let me do an example of this so that integration by parts becomes clear to you. Now any topic or any form can be understood by solving as many as problems which you can. Solve the numericals, solve the sums, variety of questions, so that you gain confidence, and it will take a very few minutes to solve a question. You won't be wasting time on it. Now, let me start off. Say I have to evaluate, question is x into sine 3x dx. Okay, just write down ILATE. This is the algebraic function. This means it's u. This is trigonometric function. This means it's v. Now, what was my formula? Formula was UV rule. What was the rule? First function integral of second function minus integral derivative of first with respect to x into integral of second and dx over here. Now x as it is, sine 3x integral is negative cos 3x divided by 3. By now you must be knowing the formulas how to integrate cos of ax dx or sine of ax dx. Minus integral x derivative is 1, this is negative, so it becomes positive. Cos of 3x divided by 3 dx. Now it is minus x cos 3x divided by 3. 1 by 3 is out. Cos 3x integral is sine 3x divided by 3 plus c. We can multiply this, it becomes 1 by 9. That is, final answer is minus x cos 3x divided by 3 plus 1 by 9 sine 3x plus of c. This is the final answer. This is how we use the u into v rule by following Eilert rule also. That is, algebraic function is taken as the first function and the trigonometric function is taken as the second function. This was the first sum from this integration by parts. I hope you have understood. Now let me do one more question from this type so that it becomes very clear and the concepts are understandable to you. Now question is, yes, it is integral tan inverse x dx. Now how to integrate it? In the beginning I have just, when I was discussing UV rule, I just discussed how to integrate sine inverse x if it is alone, all alone, right? So what I will do, I will just write down integral tan inverse x into 1 dx. Again I am going to follow Eilert rule. I means inverse trigonometric function. This becomes my u, this is my v. Now I have to integrate. This is algebraic function, one is algebraic function. Just integrate tan inverse x first function, integral second function minus integral derivative of first into integral of second. Its whole integral is there, so dx is there. It is tan inverse x minus derivative of tan inverse x is 1 plus x square into x. 1's integral is x. Derivative of tan inverse x is 1 upon 1 plus x square. Now I have x tan inverse x minus of x 1 plus x square dx. Now it is very, very simple. What is the derivative of 1 plus x square? Derivative of 1 is 0. Derivative of x square is 2x. What I have to do is I have just to multiply and divide with 2. What is the answer? X tan inverse x minus half log of the base. That is 1 plus x square plus c. This is the final answer. Now just look on. Once again I will explain you. Tan inverse x integral I have to do. I write tan inverse x into 1. Follow the Eilert rule now. First function integral second minus integral derivative of first into integral second. Whole integral is there, so I write dx. Now tan inverse x, one integral is x minus of 1 upon 1 plus x square x dx. Follow the suit and write the formulas. Remember the formulas so that you can get the final result. Here I have used the formula of integral of f dash x upon fx dx. Answer was log of fx plus c. I expect that you have learned these concepts They have been explained in my previous lectures. Hope it is clear. If a lone interval, a lone function is only one function was given, what I wrote, the function multiplied by 1, then integrated using the Eilert rule or UV rule was followed, we got the final answer. Now, one more question from this. Again, it's a very, very good sum. And it's my favorite question. Integrate secant cube x dx. I cannot write 1 over here because secant cube x into 1. I don't have any formula for the secant cube x. Right? So what I will do, let I equals to this. I can break this as secant x into secant square x. Power is 1, power is 2. Take this as u, this as v. Now integrate using UV rule. First function, integral of second function, minus integral derivative of first into integral of second. Its whole integral is there, right? Now, secant x, secant square x is tan x minus integral of secant x, derivative of secant x is secant x tan x, secant square x integral is tan x dx, right? It becomes secant x tan x minus secant x tan square x dx. Now it's secant x tan x minus, watch this step, in place of tan square x I can write secant square x minus 1 dx. Now I started with I equals to this. Let me write over here I equals to this, or I equals to secant x tan x minus of, just open the brackets, secant cube x dx minus integral secant x dx. Let me write over here I equals to secant x tan x minus of secant cube x dx and minus integral secant x. Let me check, minus minus becomes plus, it becomes plus over here, secant x dx. U into v, u integral v minus integral derivative of u integral of v dx. Integral of this secant square x is tan x, derivative of secant x is secant x tan x, integral is tan x. Solved. I got this value. Now what is this? This is I minus I. So I can write I equals to secant x tan x minus I plus, what is the integral of this? It is log of secant x plus tan x plus c. Just take this I to this side. 2i equals to secant x tan x plus log of secant x plus tan x plus c. Now I need I to divide by 2. This thing, this whole expression divided by 2. I get the answer. It was a bit different question in which only secant cube x was given, trigonometric function was given. I didn't have any algebraic function or any logarithmic function or any other function. So what I did, I broke this into secant x into secant square x. This is u, this is v. Then solved it. I got this value. This was again a repetition, that is minus I. I took this I to this side. It becomes 2i. Rest is your answer. But application of formulas is there. If you don't remember the derivative of secant x, if you don't remember the integral of secant square x, then I am sorry for you. But I hope you do memorize those formulas. You have in mind how to apply them and where to apply them, and remember the types. Remember the types of integrals which we are doing. If you remember it, and if you remember the method to solve them, how to start and finish them off, then you won't find indefinite integrals a problem for you. Nothing. It's just a game which you would like to play and will enjoy it. Now, another question. It's a very, very good sum. It is this. Evaluate. It is integral of sine inverse under root x cos inverse root x divided by sine inverse this plus cos inverse under root x dx. We have done inverse trigonometric functions, right? If you remember, what is the value of sine inverse theta plus cos inverse theta? That is pi by 2. So I can write straight away as this as pi by 2. So it becomes 2 upon pi. It comes in the numerator. Only thing left is this. Left is this. Right? Now, I have this formula. Sine inverse theta plus cos inverse theta equals to pi by 2. Using this, I can replace either this or this, change this into any one of the inverse trigonometric functions. Let me try. 2 by pi, it is sine inverse under root x minus, can I write this as pi by 2 minus cos inverse under root x, this sine inverse under root of x, using this formula. So sine inverse under root minus minus becomes plus, twice sine inverse under root x minus pi by 2 dx, it is 2 upon pi. Now 4 upon pi sine inverse under root x dx minus pi with pi goes, 2 upon 2 cancels, it is 1 dx. Now it is 4 upon pi, right? Integral of sine inverse under root x dx minus of integral of 1 is what? X plus c. Now sine inverse under root x, how to integrate it? Now sine inverse under root x, let under root x equals to t. So x equals to t square, dx की value 2t dt, right? Just replace this. 4 upon pi integral sine inverse t, dx की value 2t dt. Take out 2, I get 8 by pi sine inverse t into t dt. Follow ILATE rule to integrate this. This is your first function and this is your second function. You can use u into v. Now first function, integral of second function, let me write 8 upon pi first function, integral of second function minus integral derivative of first. Remember the formulas, t square by 2 dt. Integrate this now, t square upon under root of 1 minus t square, using your methods which I have already discussed. right? It's left on you to solve this portion. Now what I have done is, this upon this was there, I used sine inverse theta plus cos inverse theta equals to pi by 2. Pi by 2 written, it becomes 2 by pi. So I have replaced this with pi by 2 minus sine inverse theta. It becomes this. One integral is x, done. Then sine inverse under root x. This can be integrated like this, right? Now, the last question from this topic, u into v, is just coming up. But I again say, go through the formulas of integration, remember the trigonometric identities, remember the identities which we have used in inverse trigonometric functions. They can be applied as and where they are required, right? Now, the last sum of today's lecture is again a very good sum. The question is, evaluate. Now it is an NCERT question also. It is x square plus 1, right? This is log of, it is x square plus 1, then minus of 2 log x, right, whole upon x 4, x to the power 4. Now first of all, what I will do is just write like this, as it is, log of x square plus 1 minus log of x square n log m, it becomes log of m the power n dx. Denominator contains x4, I will write x cube into x. Now I can write this as x square plus 1. I take this x within the square root, I will write x square. This becomes log of m minus log of n, log of m upon n divided by, I can write this as 1 by x cube dx, like this. Now integral x square divided by x square, 1 by x square, similarly log of 1 plus 1 by x square into 1 by x cube dx. Now the sum is very clear, must be clear to you. What I am going to do is put 1 plus 1 by x square equals to t. Derivative of 1 is 0. It is minus 2 1 upon x cube. 1 upon x square, I take it in the numerator, it becomes x raised to power minus 2. Minus 2 into 1 by x cube dx is dt, or 1 upon x cube dx is minus half dt. Replace this, I get this as under root of t log of t, 1 upon x cube dx is minus half dt. Take this as minus half dt. Now we can use Eilert rule, and u into v dx, it can be integrated very easily. Now log is the first function, under root of t is your second function, just integrated like this, right? What we did was x square plus 1 under root upon x4 was there. I broke this into x cube, simplified this, I got this thing. Now I substituted 1 plus 1 by x square equals to t. 1 ka derivative 0. 1 by x square is minus 2 upon x cube dx is dt. I took out the value of 1 by x cube dx. It was minus half dt. Substituted. Now I can use Eilert rule over here to solve this integral, right? Hope this is very clear to you. I did integration by parts by giving you examples, by solving some problem sums, but now it's up to you, right? How many questions you are going to try. Try as many sums so that the concept becomes very clear, or the types which I have discussed today in my lecture becomes very clear to you. Thanks for watching my video, but those who haven't subscribed my channel, please subscribe it. Thank you very much.